Hello and welcome everyone. Good to see you all again. We'll start this off here. So we're going to start with something like this here. This is actually very similar to a problem in the homework that came before. So I wanted to focus on this here. Hopefully that will knock out, not only will this help here, but also will explain something that we did in the homework previously. So we want to determine the valid conclusion can be drawn from the statements here. So note that in this case we have some information about coffee, tea, and sleeping. Okay. So, as always, again, we want to try to convert these into symbols so we can look at these a little bit more directly here. So, I can say, we'll say C is for coffee. If we have coffee, then we will not have tea, so it's going to be C implies not T here, right? If we do not have coffee, so that's not C, implies falling asleep, in this case, A. So it looks like that we have two conditionals here. Now, wait a minute. At this point, we really only have, we don't have a lot of laws here, but we do have a law that applies to conditionals here, the chain rule. So we can try to use the chain rule here. However, we note that there's a problem here, right? You'll note that the chain rule requires us to have, first off, the identical statements, and they have to be sort of on opposite sides of the conditional here. Here, yeah, we have some identical statements here, but they seem to be the wrong signs, right? One is negated and one's sort of not. Furthermore, they're in the wrong position as well. They're in the same part of they're both antecedents here. You want one to be the antecedent and one to be the consequent of the other. So that seems a little strange. And so you realize, wait a minute, there are ways that we can mess around with this here, right? So you might recall, we talked about how with a conditional, we can change it to its contrapositive and it would still end up exactly the same. So we can take the contrapositive of either of these here. Let's say we can take a contrapositive of this, and we take the contrapositive of this, remember we can just flip it and negate, so with T implies not C here, right? And now we have not C implies A, and now we can see this does match up, and this does fall into our chain rule bit here. So we can put these together and use our chain rule. And then as a result, we end up with T implies A, which basically means something along the lines of, if we have T, then we will fall asleep, okay? Now, some of you may know, wait a minute, Mr. Chung, there's another thing you could have done here, right? You could have taken the contrapositive of this here. You can take the contrapositive of the other statement, and we end up with not A implies C here, right? And we have C implies not T, and again, we can chain these together, and we end up with, so again, we match these chain, we have not A implies not T by chain rule here, and we end up with that. So now we have another statement that says, if we do not fall asleep, then we will not have T. Now wait a minute, hold on, how could that be possible? We have two completely different conclusions here. But you might have noted that even though these are technically different conclusions, they're saying the same thing. They're just contraposites of one another. So despite the fact that these are two statements that look completely different from one another, they're saying the same thing because they're logically equivalent. So it really doesn't matter which one you have here. Either of these are perfectly valid conclusions because they will both end up exactly the same place at the end. Okay?